Are you preparing for Spring Boot interviews and facing questions about cold start performance? In this video, we dive deep into the most commonly asked Spring Boot cold start interview questions and answers perfect for backend developers, DevOps engineers, and cloud-native architects. Whether you're deploying to AWS Lambda, Kubernetes, or just want lightning-fast boot times, this video will help you optimize and explain Spring Boot cold start behavior with confidence in your interviews. 1. What is a cold start in Spring Boot? Answer. A cold start refers to the time it takes for a Spring Boot application to become ready to serve traffic after being started for the first time, e.g., after a container is started or a Lambda is invoked cold. This includes JVM startup time, Spring context initialization, dependency injection setup, bean creation and auto wiring, class path scanning and annotation processing. 2. Why are cold starts a concern in Spring Boot applications? Answer. Cold starts are concerning because Spring Boot apps can take several seconds to start, especially with many dependencies or large configurations. In serverless or on-demand scaling environments, e.g. AWS Lambda, GKE Autopilot, this latency directly affects user experience. Cold starts can lead to timeouts or failed health checks in Kubernetes probes. 3. What are common causes of cold start delays in Spring Boot? Answer. Too many beans and annotations at component, at service, etc. Heavy class path scanning. Synchronous I/O on startup, e.g. DB connections. Large configuration files. Use of complex frameworks, e.g. Hibernate, Kafka, etc. Loading of unnecessary auto-configurations. Blocking initialization tasks, e.g. migrations, external API calls. 4. How can you reduce cold start time in Spring Boot? Answer. Use spring.main.lazy initialization equals true to load beans on demand. Exclude unnecessary auto-configurations using at Spring Boot application exclude equals. Minimize third-party libraries and dependencies. Use lighter embedded servers, e.g. Netty instead of Tomcat. Profile the startup with spring.boot.startup.metrics.enabled equals true. Pre-warm the JVM or use native images GraalVM if possible. Initialize database lazily or asynchronously. 5. What is lazy initialization and how does it help? Answer. Lazy initialization means beans are created only when required, not at startup. This avoids creating all beans up front, reducing startup time. Enable it in application.properties. Spring.main.lazy initialization equals true. 6. How can Actuator help with cold start diagnostics? Answer. Spring Boot Actuator provides startup metrics /actuator/startup, bean initialization times, context load phases. Use management.endpoint.startup.enabled equals true. 7. Can using native images reduce cold start time? Answer. Yes. GraalVM native images can reduce startup time from seconds to milliseconds by compiling the app into a native executable, eliminating the need for JVM warm-up. Tools. Spring Native deprecated. Spring Boot 3 plus GraalVM support via AT processing. 8. What is the impact of Spring Boot version on cold start? Answer. Newer versions, especially Spring Boot 3 plus, have better AT ahead-of-time processing, improved lazy loading support, enhanced startup metrics, native image support with minimal configuration. 9. What is AT processing in Spring Boot? Answer. AT ahead-of-time processing generates static code during build time to avoid reflection and class path scanning at runtime. Significantly improves startup and memory usage. Required for native images. 10. What profiling tools can you use to analyze cold starts? Answer. Spring Boot Startup Actuator, JProfiler/Visual VM, Micrometer Metrics, Java Flight Recorder, JFAR, Cloud Provider Monitoring Tools, e.g. AWS X-Ray, GCP Profiler. Don't forget to like, subscribe, and hit the bell icon for more Spring Boot, microservices, and cloud engineering content.